Now question 4 says the line y equals to k minus 3x, that is k minus 3x, right, is tangent to the curve x square plus 2xy minus 20 is equal to 0. For this, we need to find value of possible values of k, and for each of these values, find the coordinates of the points of contact of the tangent with the curve. Okay. Now, this would be a quadratic curve and this would be a straight line if we consider this be tangent. So now what we have to do is we have to substitute this value of y here. So that would be x square plus 2xy, that is k minus 3x. Okay. Minus 20 equals to 0. So it is going to be x square plus 2kx minus 6x square minus 20 is equal to 0. So let's rearrange it. That makes it minus 5x square plus 2kx minus 20 is equal to 0. We can take minus common. That makes it 5x square minus 2kx plus 20 is equal to 0. So what we have done, we have simply substituted this linear line into the quadratic. So that was y equals to k minus 3x. This was x square plus 2xy minus 20 equals to 0. So we replace y with k minus 3x here, nothing else. And we rearrange it 2kx minus 6x square. Then it would become minus 5x square plus 2kx minus 20. Then we take minus common. That makes it 5x square minus 2kx plus 20 is equal to 0. Now, Ahmed, if they claim that this line is tangent to the curve, for what value of k this line is tangent to the curve, then what should be the scenario for discriminant? Yes? We would say discriminant must be equal to 0, right? So we have b square minus 4ac is equal to 0. That would be minus 2k b square minus 4ac is equal to 0. That would be 4k square minus 400 is equal to 0. You can take 4 common, making it k square minus 100 is equal to 0. Then you can divide 4 over there. K square minus 10 square is equal to 0. So that would be k plus 10 into k minus 10 equals to 0. That would be k plus 10 equals to 0 and k minus 10 is equal to 0. So two values of k are 10 and k equals to minus 10 and k is equal to 10. Yes, Ahmed, Alina, Ayan, is that clear? We simply had one linear and one quadratic equation, right? A linear and a quadratic equation, okay? And we substituted this in quadratic. We have a quadratic equation, and then for tangent, the discriminant must be equal to 0. Any questions so far?
No, sir.
Okay. Now they say in question, they have for each of these values of k, find the coordinates of the point of contact of the tangent with the curve. Ayan, is it clear, beta? Any question?
No.
Okay, that's it. Ahmed?
एक मिनट से देख रहा हूँ.
Ahmed, we have a quadratic equation here, okay, and we have a linear equation. Or claim ye kar raha hai that this is tangent to the curve, right? So what we do is we simply substitute y in quadratic equation, making it quadratic in x. Okay? And then since this line is tangent to the curve, हम ये बोलेंगे कि discriminant must be equal to 0. So your this discriminant b square minus 4ac must be equal to 0. So that would be b square minus 4ac is equal to 0. We rearrange it and we find value of k. So values of k are 10 and minus 10. Now they say for each individual value of k, find out the possible values of x for which For each of these values of k, find the coordinates x and y both for the points where this line is tangent to the curve. So now what we do is we investigate for both values, for k10 and for k minus 10, right? So for k10, it's going to be 5x square minus 2 into 10 into x plus 20 is equal to 0. Now we will have to solve this quadratic equation. So that would be 5x square minus 20x plus 20 is equal to 0. We take 5 common, that makes it x square minus 4x plus 4 is equal to 0. That would make it, you can divide 5 on both sides, cancelling it x square minus 4x plus 4 is equal to 0. Now we know that this is x minus 2 whole square, right? Making it equals to x equals to 2. Okay, now we have x is equal to 2 and k is equal to 10. You go back to the linear equation that was k minus 3x. Y equals to k minus 3x. So k is 10, x is 2, y is 4. So point is 2 and 4. That is my first point, first possible point, right? Let's name it A. And we would repeat the same process for k is equal to minus 10 now. Okay. Now if k is minus 10, then it would be 5x square minus 2 minus 10 20 equals to 0. And that would be 5x square plus 20x plus 20 is equal to 0. Let's take 5 common, making it x square plus 4x plus 4 is equal to 0. Dividing 5 on both sides, it cancels out. We have x square plus 4x plus 4 is equal to 0. And that would be x plus 2 whole square equals to 0. That means x plus 2 is 0 and x is equal to minus 2. Now we have x as minus 2 and k as minus 10. Then it's y is equal to k minus 3x. Now k we are taking as minus 10. X is minus 2. Okay. That is equal to minus 10 plus 6, making it minus 4. So that would be minus 2 and minus 4. This is second possible point where the straight line is tangent to the curve. Is it clear? Yeah. Any question? Ayan, Alina, is it fine?
No, no questions.
Okay, that's great. Alina, clear है बेटा?
जी सर
Ahmed? Okay. So if you people are done, can we move to next question? Ahmed?
यस सर
Yes, sir.
Okay. I guess question 5 is exactly the same. I'm going to solve it on board, but I want you people to give it a try, okay? And once you are done, you can send it to me on WhatsApp. Okay? Question number 5. In question 5, we have find the values of m for which y equals to mx plus 6. It is exactly the same what we have just done. Y equals to mx plus 6 is tangent to the curve y equals to x square minus 4x plus 7. Ayan, can you explain a bit what we are going to do in this question, provided they have given that this is tangent to the curve? Any idea?
You put equation 1 is equal to equation 2 because they're both y. and then
Yes.
move everything to one side.
Make it a quadratic.
Yeah. Then after that, put the quadratic equal to 0. And
Discriminant.
yeah. The
B
discriminant
square.
b square minus
Yeah.
4ac is equal to 0.
And why we are putting it equal to 0? Because
It's a
they have
tangent.
given that this is
Tangent by
tangent.
1.
Shabash. Excellent. So x square minus 4x minus mx plus 7 minus 6 is equal to 0. So that gives us x square minus 4 plus mx plus 1 is equal to 0. So by simply substituting this linear equation into quadratic, we get a quadratic equation. Okay. Now, since this line is tangent to the curve, then it has to be discriminant has to be equals to 0. So b square minus 4ac is equal to 0. So that would be simply minus, that is 4 plus m b square minus 4ac is equal to 0. That would be y 4 plus m square minus 4 is equal to 0. Okay. Now it's up to you. You want to open a plus b whole square, or we could do it in another way as well. 4 plus m whole square is equal to 4, and then we can take square root on both sides, cancelling it, giving us 4 plus m is equal to plus minus 2. And then we have 4 plus m equals to 2, and 4 plus m is equal to negative 2. Lina, you got this move, beta? Is it clear? We simply took square root on both sides.
Yes, sir.
Okay. And now we get values of m. Okay. Either m is minus 2 or m is minus 6. Okay. Do we have to find some other thing as well? For each of the values of m, find the coordinates of the point where the line touches the curve. So that's again y equals to mx plus 6. And so m is minus 2. When m is minus 2. So x square minus 4 is equal to 0. So x square minus 1 is equal to 0. That would be x square minus 2x plus 1 is equal to 0. That is simply, what do you say it? X minus 1 whole square is equal to 0, giving us x is equal to 1. So now we have y equals to mx plus 6, right? M is minus 2, x is 1 plus 6, giving us 4. So first value is Alhamdulillah. First value is 1 and 4. Second value, when m is negative 6, now let's try. That would be x square minus 4 minus 6, x plus 1 is equal to 0, right? That makes it x square minus 2x plus 1 is equal to 0, making it x square plus 2x plus 1 is equal to 0. That would be simply x plus 1 square equals to 0, making it x is equal to minus 1, right? And its corresponding value for y would be, we have y equals to mx plus 6. So m was minus 6, x is minus 1. That is equal to 12. So y value is 12. So second option is it's x is minus 1 and y is 12. Usually if they give this question in exam, it's going to be a 5 or 6 mark question. Okay, done?
Yes, sir.
Ayan, are you getting something, beta? Ahmed?
Yeah.
Okay, that's great. Ahmed, what about you? Ahmed, can you hear me? Done, beta?
Yes, sir.
Okay. Alina, could you explain the last question, question 6, beta? What we are going to do here? It says find the set of values of k for which this line intersect the curve at two distinct points. Okay. Now in question 6, this is the scenario that it's going to be intersecting at this point. So if a line intersect the curve at 2 points, then b square minus 4ac is going to be greater than 0. Okay. Right?
Yes. Yes, sir.
So we're going to do it. Y equals 2x minus 1. Okay. And y equals to x square plus kx plus 3. Yes. We're going to simply substitute this y here, and then we would be putting discriminant greater than 0. Now we have, sorry, 2x minus 1 is equal to x square plus kx plus 3. So we have x square plus kx minus 2x plus 3 plus 1 is equal to 0. So that gives us x square plus k minus 2x plus 4 is equal to 0. Right? So if this straight line intersects a curve at two unique points or two different points, then b square minus 4ac discriminant must be b square minus 4ac must be greater than 0. So here you go. That is k minus 2 b square minus 4ac is greater than 0. K square minus 4k plus 4 minus 16 greater than 0. K square minus 4k minus 12 greater than 0. Okay. Now that is going to be k square minus 6k plus 2k minus 12 is greater than 0 plus 2 k plus 2 and k minus 6 is greater than 0. In the beginning of this chapter, we have solved quadratic inequalities in which we have learned about the roots. So if leading coefficient k square is positive, that means it's going to be a smiley face or concave up. Okay. Now k plus 2 is equal to 0 and k minus 6 equals to 0 gives us k is equal to minus 2 and k is equal to 6. That means this is minus 2, this is 6. This greater than 0 tells us that we are interested in the area on the portion where curve is above x-axis. Okay. Above x-axis. So you see this is the part where curve is above x-axis. So values of k are going to be greater than 6 and less than minus 2. These are the answers. Either k is less than minus 2 or k is greater than 6. That's how we solve a quadratic inequality. Is that clear, beta? Yes.
Yes,
First
sir.
two questions we did for tangent. For that, discriminant had to be put equal to 0. Then next question was when the discriminant is going to be uh, greater than 0, because now they want us to investigate for values of k where the gradient is where the line cuts the curve at two distinct points. Okay, Ayan, is that clear? अहमद ये वाली बात समझ आई सारी?
सर थोड़ी कम समझ रही है।
जी बेटा, कहाँ से?
नहीं सर, जब सॉल्व करूंगा शायद हो जाए सही।
अच्छा, मेनली हम ये तीन बातें डिस्कस कर रहे हैं. जस्ट हैव अ लुक. फॉर अ स्ट्रेट लाइन and a curve, either this is going to happen or this is going to happen or this is going to happen. ठीक है, तो एक लीनियर हुआ करेगी, एक क्वाड्रेटिक हुआ करेगी. तो सिंपली जब आप लीनियर को क्वाड्रेटिक में पुट करोगे, इट विल बी a quadratic equation. And if this is the scenario where the straight line intersects the curve at two different points, two distinct points, we would say b square minus 4ac must be greater than 0. Okay, ठीक है. अगर ये क्लेम करे इट हैज टू बी टेंजेंट और एक जगह पे कट करेगा, देन बी स्क्वायर माइनस 4ac मस्ट बी इक्वल टू 0. ठीक है. और तीसरा सिनेरियो ये है कि लाइन कट ही ना करे, डज नॉट इंटरसेक्ट, then it is going to be b square minus 4ac is less than 0. ठीक है. तो हम यही बातें बार बार रिपीट कर रहे होते हैं. ओके, Amit, is it clear now? We'll be having only these three scenarios: greater
Yes.
than 0, equal to 0, less than 0. If they want us to investigate for a line intersecting curve at two different points, your discriminant is going to be greater than 0. Tangent, it must be equal to 0, and if the line does not intersect the curve, it has to be less than 0. Okay, makes sense? Everyone? Alina, is it clear? Ayan?
Yes.
Yes, sir.
Okay. Let's try to solve a past paper question now. By the way, you have to complete this exercise. Okay, you have the book, you have to give it a try. Okay. So for question number 10, we have, here it is. Part A is easy. They have already given k is 2 and the line, the curve intersected point A and B, find the distance AB. So that's fine. Question 2 हम अभी investigate करेंगे. Find two values of k for which the line is tangent to the curve. So this is the curve and this is the line. So yes, when we claim that this is tangent to the curve, then after substituting, we have to put b square minus 4ac equal to 0, right? For being tangent. Is that clear? Yes. So y is equal to kx plus 6. ठीक है. and y is equal to x square plus 3x plus k. Oh, sorry, 2k. So first of all, we are going to, substitute it. Kx plus 6 is equal to x square plus 3x plus 2k. That is x square plus 3x minus kx plus 2k minus 6 is equal to 0. 3 minus k x 2k minus 6 is equal to 0. Ahmed, यहाँ तक clear है बेटा? We just substituted linear into quadratic. That's it. Yes? Ahmed, are you there बेटा?
Yes, sir.
हमने क्या किया अभी? We have simply substituted linear into quadratic, right? And we have a quadratic equation. If we claim that this is the tangent, then discriminant must be equal to 0. So that is b square minus 4ac is equal to 0. This is going to be 3 minus k square b square minus 4ac. That be 2k minus 6 is equal to 0, right? So that is 9 minus 6k plus k square minus 8k plus 24 is equal to, that would give us k square minus 14k plus 33, I guess, equals to 0. Then we have to factorize it, I guess. Okay, so we have 1, 14 and this. That is your A, B and C. So now we have B square, because this would be tangent. Oh wait, no. We just need to find value of k now. Sorry. So we're going to use k square minus 11k minus 3k plus 33 is equal to 0. So k into k minus 11 minus 3k minus 11, right, is equal to 0. So that would be k minus 11 into k minus 3 is equal to 0. That gives us k equals to 11 and k equals to 3. So we're getting same type of questions here, where either it's going to be greater than 0, equal to 0 or less than 0, right? So any question related to this? Ahmed, बताएं बेटा. Okay.